Okay, guys, so first we're going to start by going over the warm-up. So let's take a look at these problems here. So on the first problem, this is the one we started with this linear function of negative 3x plus 1. We wanted to find g, that's the name we have to give it, such that f of x has been shifted 2 units to the left, 4 units down. Who knows how we can make a shift of 2 units to the left? What do we do?
Plus 4. Plus 2.
Okay, and I don't want you to just say plus 2. It's actually a replacement. Like, it's not that I can just put x plus 2. I need to actually replace this x with x plus 2. Watch the notation. I'm going to say that I'm going to do f of x plus 2. That means everything stays the same, but wherever I have this x circled, I'm now going to replace it with x plus 2. And that is going to shift us 2 units to the left. Okay? Remember how with x's, it's kind of like the opposite of what you would think. If you're going to the left, you almost feel like it should be x minus 2, don't you? But that's not really true. Let's look at it on the calculator. And I've told you guys how you really want to practice with the calculator too, because it just helps you so much on the ACTs and everything. Negative 3x plus 1. Now watch, negative 3 parentheses x plus 2 plus 1. So here's our original function, and here's the new function. It should be a shift to the left 2 units. Can you see how it did shift to the left 2 units? Like, look at this point right here. That went to the left 2 places. What is that point right there? 0, 0, 1. Look at the table. So, let me start it at 0. I'm doing a lot of stuff you haven't learned yet, but so 0, 1 is our first one. If I shift 0, 1 to the left 2 units, where is it going to be now? 0, 1 shifted to the left 2 units. Where is it going to be? Negative 2, 1. Do you see how now we have that point? Negative 2, 1 on the second one, on the red one. Okay? That's how I'm checking that. All right, now we want to simplify this. So another name for this is negative 3x minus 6 plus 1. But we're not finished, because we also want to take this 4 units down. So now we have to take that function we had, and what do I have to do with it? Subtract 4 from the entire function. So I'm going to have negative 3x minus 5 minus 4, and so our new function for g is negative 3x minus 9. Did anybody get that right?
Yep.
Raise your hand if you got it right. Ooh, I want more than that. What did you do wrong? Did you just do negative 3x plus 2 instead of distributing it? Okay. It's a replacement. Whenever it's with an x, it has to be a replacement. Okay? Yep.
So we do the 2 units to the left first, and then we do the 4 units down.
Correct.
So we can't. So I just had negative, and then or negative 3, and then parentheses x plus 2. And then I had that, and then I had the plus 1, and then I just did 4 units down, so I changed the plus 1 to minus 3.
Okay. So this is what you had for your answer right here.
Yeah.
That's right.
That works.
Why is that right, guys? Yes?
Because it's technically the same equation, but it's not simplified all the way.
Right. This is the same. Look, if you multiply this out, Josh, you'd get negative 3x minus 6 minus 3. See how it's the same thing?
Yeah.
Okay? If you're not sure it's the same thing, you could put in your calculator and see that it's exactly the same line. Okay? So you could have this or this, but if my directions say to write it in simplified form, you need that. Okay. Let's go on down to the second one. Here was our function, f of x equals 3x squared minus 2. Find g such that the function has been shrunk vertically by a factor of 1/2. Okay, anybody think they know the answer for g? Raise your hand if you know the answer to what you think g might be. Come on, give it a shot. Doesn't matter if it's wrong. What'd you get, Jada?
3 over 2x squared minus 1.
Like that? Anybody else agree? She's right. Okay? If I graphed it, I could see that she's right. But here's what happens. If I want to shrink vertically by a factor of 1/2, I have to take my function, multiply the entire function by 1/2. So I have to do 1/2 times that entire function. And then she just went ahead and distributed it. Okay? How many people got that one right? Yay, more. Okay, let's go to the last one. Cubic. Do you guys remember what cubics look like? You should. It's right there on the board, right? So we have a function, x cubed plus 1. Find g such that the function has been stretched horizontally. Ugh. Horizontals are harder than verticals. We have to stretch it horizontally by a factor of 3. Does anybody know how to make that happen? What do you think, Chloe? Okay, really close. You're right on the 1/3. I think you just meant x cubed and you said x squared. Okay, so she's right. Here's what I'm going to do. I have to do f of 1/3 x. So with x's, it has to be a replacement. Wherever I see this x, I have to replace that x with a 1/3 x. Where does that cube go? On the inside or the outside? Outside. The circle's becoming a parenthesis. Did anybody have this answer for G? All right, I like it. It's good. Better would be if it's simplified. Do you know how to cube the 1 and cube the 3? 1 cubed and 3 cubed. What is that? 1/27 x cubed plus 1, right? All right. So that's going to be our answer for that horizontal stretch. It doesn't feel like that's a stretch, does it? Just let me show you though, because I know how that goes. Like you think that doesn't seem like a stretch. But watch, x cubed plus 1 compared to 1/27 x cubed plus 1. Watch it. Here's the original one. Here comes the new one. Can you see how that is stretched horizontally by a factor of 3? We feel like it's not right, but it is. Look when I look at my table. I'm going to take a point. 1, 2. If I stretch this horizontally by a factor of 3, what's 1 be turned into if I multiply it by 3? 3. 1 times 3 is 3. Look at the point I have in red. 3, 2. You see what I'm talking about? 1, 2 now becomes 3, 2 on our new one. That's a horizontal stretch by a factor of 3. Nothing else happened. Okay? Last thing we had to do was write the domain and range. What's the domain and range here, guys? Yep. This is the way we write that. Sometimes people want to put less thans and stuff in this. This is not, we don't need any less thans when we use interval notation. That's how we write it. Okay? Anybody get all 3 right? All right. A couple of you did. Good. Okay. Get out your notes. Section 1.3. Let's move right into these. Okay, guys, so we're talking about lines of best fit. We're going to be given a bunch of data, and we're going to come up with a line that best fits through that data. Sometimes we're going to have a bunch of points. Other times we're just going to have a few points. And we want that line that goes best through those points. So if I give you a bunch of points scattered around like this, okay, I can get a line of fit, a straight line that goes through these points. But the line of best fit takes into account every single point. It's like it's finding the slope for all these points, and it's finding the line that best goes through them. That's what we're going to be finding. We're also going to be looking at a correlation coefficient. The closer that this correlation coefficient is to 1, if it's close to, where is it, 1? If it's close to 1, then the more linear the relationship is. If it's close to -1, that means a strong negative correlation. It's very linear, but it has a negative slope. If the R is very close to +1, it's a very strong positive correlation. It's very linear and it has a positive slope. Okay, so that's what this R is going to tell us that we're going to come up with. Right now, you don't even know what R is, but you'll see here in just a second. All right, writing the equation of a line, if we're given the slope and the y-intercept, we can use this. If we're given a point and a slope, we can use this or that. If we're given 2 points, we got to find the slope first, and then we can use this or this, whichever we prefer. We're doing this without the calculator first. Find the equation of a line passing through 5, -2, and 3, 6. That's all we're doing first. If I have 2 points, what do I need to find? The slope. So I've got to find the slope first. All right, let me find that slope. Guys, let me pause for a minute. All right, let's keep going. So we're going to find the slope here. To find the slope, we're going to have to do 6 minus -2 over 3 minus 5. What's that going to give us? On the top, what's the slope going to be? 8. What's the denominator going to be? What is that slope? -4. So we have a slope of -4. Now you have options. You can use either this or this. I personally like this one better. Okay, so I have a point. I can use either one. Which do you think's better? I always use one that doesn't have negatives. I'm using this one. So I am going to use y equals mx plus b. I'm going to plug in for x and y, and I'm going to plug in for m, and I'm going to find b. So if I'm going to use this point, what's y? What's m? What's x? 3. I'm trying to find b. B is going to be, that's -12 added over. What do you get? 18. So the equation of this line is y equals -4x plus 18. Watch how I'm going to check my work. We're saying this is on the calculator part of a test. Just watch. You don't need to follow along yet. I'm going to put in -4x plus 18. I'm going to graph it, and I'm going to look at my table. Watch how I check this really quickly. Second graph to get to my table. What points this is supposed to pass through? It's supposed to pass through 5, -2, and also through 3, 6. Is it passing through those 2 points? So I'm good. I know I'm right. Okay? Now I'm going to show you how to have the calculator come up with this for you. Now we're going to this paper. All right. So you are going to go to, and follow these directions. First thing you have to do is you've got to choose stat plot. Choose stat plot. Stat plot is right here in blue, so we're going to have to push second y equals to get to it. If you don't have a calculator, I see a couple more over there. You need to practice this. It's going to feel really difficult if you don't practice it. So I'm going to hit second y equals, I'm going to hit enter. And I want to turn this on by pushing enter and making sure it's on. We're going to use this first type. I'm going to check my X list. It has to be L1, which it is. My Y list has to be this. Choose whichever mark you want. I'm going to change it up. I'm going to use this one this time. I just push enter. And then I'm going to choose a color. Let's go with green. And I'm going to push enter. Everybody got that all set up? You don't have to use my same choices on these two. I'm just choose which one. All right, so now I have to quit. Do you guys see this quit button right here? Very important you know how to use it. Second mode to quit. We want to get out of there. All right, now we want to clear out any equations we have. So we're going to go to y equals, and see how I have that old equation in there? I'm going to hit clear. Do you guys have anything in there or not? Okay, if not, you're good. Okay, now I'm going down to step number 2. How do I get out of here, though? I don't want to be here. What do I do? Quit. Second mode. So now I'm on step 2, and I'm going to go to Stat, Edit. So see the Stat key? It's right here. Right there. Stat, Edit. And I'm going to push Enter. Now, do you guys have anything in here? Probably not, but if you do, you go to the top, you hit Clear, Enter. I go to the top, I hit Clear, Enter. So now I'm going to put in my points. So the points that we have for this problem, x is 5, and then x is 3. Enter. Every time you push Enter. I go over to my y's. Y is -2 for the first one, and it's 6 for the second one. And now I want to quit, so I'm going to second mode to quit. All right, so I'm going to check our answer this way too. Here's where we go back to this paper, and I want to see these points. I want to take a look at them. So everybody hit graph right now. Does everybody see the 2 points? All right, it's not very dark. Okay, so now I'm going to go ahead and I'm going to figure out the regression equation, guys. We're down here, finding regression equation number 2. Push Stat, Calculate. We're going to choose linear regression, which is number 4, because it is linear data. I'm going to push Enter. Oops. Okay, if you have an old calculator, you're just going to push Enter again. If you have one like mine, you have to go down here to Calculate, and then you got it. Now, how many people do not see R equals? Okay, that's because we haven't turned on your diagnostics. You're only going to have to do this one time. If you do not have R equals, follow along with me. You're going to go to the catalog. So you're going to do second, 0 to get to catalog. Now I want to go down and I want to do diagnostics on. So instead of sitting here and scrolling down to the D's, I'm going to push the letter D. Just push D. And get down there to where it says diagnostic on. And push Enter, and then push Enter again. And it should say done. Anybody need help? All right. Now we want to clear. And we're going to go to here now. This diagnostics on, like I said, you don't have to do that part. Now we're back to where we do have to do this. Go to Stat, Calculate, go down to linear regression again, and now when you do this, sorry, I keep pushing the wrong buttons because I'm not looking. Now you should see that R value. Is everybody seeing it? Okay, so -1, is that a strong correlation? Yeah, it's a very strong correlation. And what the negative tells us is it should have a negative slope. All right, so let's look at the equation. What is the equation? Well, A represents slope for this, and B represents the y-intercept. Is that the same answer we got? -4x plus 18. Okay, let's type it in. Go to y equals -4x plus 18. Hit graph. See how it goes right through our 2 points. What's wrong, Josh? Invalid? If it says error, you probably push -4x instead of -4x. when you did y equals? What's it say exactly?
I don't know, I closed it out a bit. So after we're here at the R -1, where do you go?
Now go to y equals and type in the line. Negative, not minus, but negative 4x plus 18. Did you get a line now?
Yeah.
Okay. Everybody got a line? Okay. Let's go on to more difficult things now. This is all that's what our directions tell us to do. Okay. Here we've got some interesting data. Find a line of best fit for this following data. If we walk for 5 minutes, we're going to burn 27 calories. If we walk for 10 minutes, 43, 15 minutes, etc., etc. Would you guys know where to get started if we want a line of best fit for this? Do you remember how to start? Actually, while you're at y equals, go to y equals first and just clear out anything that's there. All right, so now we're going to quit. Where do I go to put these points in? Does anybody remember what those are under? Stat, then what? Edit. I go up to the very top, I clear, enter. Very top, I clear, enter. We're going to put in all of our X's. 5, 10, 15, 20, 25. We're going to put in all of our Y's. Before you go any further, guys, make sure you have the same number of X's and Y's. See how they have to end at the same spot? If they don't, you're going to get an invalid dimension error. Any questions there? Quit. Go to your home screen. We're going to find that. Actually, let's look at the points first. I want you to hit graph. We are not seeing our points. So what we have to do is we have to go to window. The smallest X I'm going to see is -10. Largest is +10. Smallest Y I'm going to see is -10. Largest is +10. Are these points going to fit in there? No. So we have to go to our X max. What should I make it if I want to be able to see all these X's? 40. 40 sounds good. Actually, I'm going to go 30. Okay, Y min, -10 is fine, but what am I going to have to make my Y max? 100 is good. Now hit graph. There's our points. All right, so we're seeing our points now. Raise your hand if you need help. Okay, what's going on? You're not seeing your points still? Okay, can somebody help right around her? See if you can help her. Go to window. Make sure she's got it set up right. If somebody around you's having help, help them out. Needs help, rather. All right, guys. Okay, so now we're going to quit. We want to quit. Second quit. Second mode to quit. Where our whole goal is to come up with this line that we need. So we have to go to stat. Do you remember where to go? Calculate. Which one do I want? Linear. It's linear. It's not a quadratic. Push enter. For the older calculators, hit enter again. For the newer calculators, go down here to calculate. There we go. Here's our equation of our line. Y equals 3.14x plus 11.3. Go back to y equals. Type this in. 3.14x plus 11.3. Push graph. good, doesn't it? Who doesn't have a line? Help your partner or somebody around you if they're not getting the line. All right. Okay, guys, let's go down here now. How many calories will you burn by walking 40 minutes? Yeah? More than 90, right? We know more than 90. Guys, I want you, does anyone have an idea of how we can figure that out? Let me rewrite this. Calories is equal to 3.14 times the minutes plus 11.3. I'm writing this in terms of calories and minutes. If I want to know how many calories I'll burn by walking 40 minutes, where am I going to plug in the 40? M. I can literally type that in, but I want to show you some other ways. Guys, you should be able to think of this. Where's somewhere that we've gone to find points before? Somebody whispered it. Table. Go second graph. Go to table. What am I going to have to do? Look for when X is what? I don't feel like sitting here and scrolling down to 40. Let me show you another way. This is new. Watch. Second trace. We want to calculate a value when X is what? 40. It's telling me it's invalid. Guys, this stuff is going to happen a lot. You have to figure out why. Hit enter and quit and think about why it's not letting me check X equals 40. You got it, Sam. Go to your window. Do you guys remember when you suggested 40 and I said, no, I'm going to use 30? That's because I wanted this to happen, okay? I didn't want us to be able to check 40. So we have to know that when we can't check a number, we have to change this to 40. I might even go up to 50 just to be sure. All right. Do you think 100 for the Y is going to be good? Probably not. I mean, the Y is not as important as the X. I'm just going to take it up to, I'm going to take it up to 200, see what happens. All right, here we go, graph. Okay, so now I'm going to do second trace to calculate a value when X is what? What am I trying to figure out again? 40. There we go. Did you guys get it? 137? Did you guys get 137 calories? Okay. Last question, guys. This is it. We're going to stop here after this one. How long do you have to walk to burn at least 250 calories? At least. At least. What's one thing I could do? I can go through this table, can't I? And I can sit here and I can look for 250. Ugh, I'm not a patient person. I'm going to quit. What I'm going to do is I'm going to go to Y equals. What do I want Y, my calories, to equal? 250. So I'm going to put in Y equals 250. All right, now I'm just going to warn you, things are not going to be great here. We're going to hit graph. I need to see that Y equals 250. Why am I not seeing Y equals 250? There you go. We got that down, don't we? The Y max is only 200. You guys said 300, and I said, no, I'm going to go 200, just so you had to suffer through this. All right, so here we go. Oh, my goodness. What's wrong? They're still not intersecting, okay? My Y is okay. I can see my red line, but I want to see where these are equal. So go back to your window. What do you think we need to do? X max, let's go big. Let's go 200, just so we don't have to mess with this anymore. All right, guys, now here's what you need to really watch. I want to know where this is at least that much. So I want to find the intersection point, right? Second trace, calculate. Which one do you think I want to go to? Intersect. Now watch this. This is weird. It's going to say, is y1 your first curve? I push enter to say yes. Is y2 your second curve? I'm going to push enter to say yes. This is so weird, but it'll now say, do you want to guess? Not really. I push enter, though, to say yes. And here's where they intersect. At 76.01. Yeah.
Will this be like written those for our upcoming test?
All right, guys. Now I want you to think about this for a minute. This is the answer, 76.019, etc. What if I said to the nearest minute, what is the answer? 77 is actually right. 76 is not right. If I round this to the nearest minute, it would be 76, but watch. Second trace, calculate a value when x is 76. Did I burn at least 250 calories? No. So what do I have to make it then? I got to go 77 minutes, and then I'm going to be just slightly over 250. Okay? All right, you guys feel like you can work with this calculator on your own?
Yeah, but now it's not just you.
It didn't put you have to put it there yourself. What do you mean it didn't let you? What did it do? What did you put? Stat calculate. You went here to linear regression. And what's it saying when you go down to here and push enter? Well, that's because you didn't go to y equals and put it in. You have to put it in. The calculator can't do everything for you. What other questions, you guys? Ask. Please ask if you have a question. Okay, that's because your stat plots aren't on. Go second y equals and make sure that this number 1 says on. Does it say on? Okay, it needs to be blinking. And now push graph, and now you should see them. Guys, one more thing here I want to talk to you about. Let's say we're doing a completely different problem, and we just want to see what does x cubed look like, and then we graph it, and we're looking at it, we're like, what in the world? This is not what I expected. Can anybody explain what all is going on with this picture? Yep, that x max and min. I can fix that quickly by doing a zoom what? 6. Okay, now let's see what, oh, that's what we think it should look like. Okay, what about those random dots I was seeing? Well, I'm not seeing them now because they're all so big that they're outside of my window. But if I did not want to see them, all I do, let me show you a shortcut way actually. Go to y equals. See how that's highlighted? That means it's going to be plotting those points. If I don't want those to be plotting, I just make it so it's not highlighted. Now there will not ever be any points there. Okay? If I want to turn them back on, like a quick way for you to turn those back on, go to y equals, go up here, click it, and I want to see them actually. Watch, now they'll be there again. Okay, you guys got that? If I don't want to see them, I go up here, turn it off, hit graph. Where are they? Disappeared. Okay? All right, everything you wanted to know about that.